So we'll go ahead and talk through this, or some of this. A common methodology that comes up is setting up kind of the given information into these equalities. I believe this is coming from your math classes, or at least some math classes. And in and of themselves, they aren't necessarily a problem. But part of that process is that you understand what you're trying to navigate and what equalities you need to be working with to navigate your solve. Okay? Which ultimately means you knew the answer to solve the question. That's problematic. Okay? Or you knew a formula to go through and plug in. Okay? It's not necessarily wrong, but it is problematic. And where it really shows its kind of all I can think of is hairy underbelly problems with it. I don't know why. Don't ask. Is when we try and track the units. And so if we look at this unit work, 1 mile is 1.61 kilometers, 63.6 miles is 102.396 kilometers. So they're using the ratio above, which then equals an hour. We would argue, where did that hour come from? It just kind of fell into that expression. Right? And then they move through to a different calculation. Now they're actually switching the entire format process into a division process, which in and of itself, again, isn't bad, but the consistency of tracking your units starts to wear thin. Okay? Holding all of those units in your head becomes very questionable if you have to string together 3 or 4 different conversions. And in this particular question, we get to 5.61, and then, well, what do I do? Well, what were the units on 5.61? Well, they weren't written there. Yeah, that becomes kind of the challenge in understanding what those calculations were navigating through, and it can lead to dead ends. Maybe, maybe not. It just depends on the scenario. Okay? So what is the approach that I would recommend? Well, first and foremost, I would recommend that you start taking that given information and list the given information out so that you know you've got it. Okay? You'll see this 63.6 miles. Okay? Technically miles per hour. I will see people go through and write miles per hour. I will see people be like, oh, the per means division, so I'm going to write a /hour. Technically, there's nothing wrong with that, except that when it makes it into an expression to solve, this is what shows up. That's wrong. That's now miles per hour. That's an acceleration, not a velocity. Okay? So that slash holds meaning, and it does mean division. Use it right out of the gate. Miles per hour. How many hours? 1. Okay. That gives us our clear numerator and denominator. Where's the slash notation coming from? Why? But why use that slash notation? Why don't we write it as a fraction? What's that? That starts to push it, but in a written out problem, why can't we write it as 63.6 miles over 1 hour? Takes up too much space, and if we talk about trying to write a question down, writing it in this fractional notation is not an easy thing to do 20 years ago. Right? And if we consider where most of these problems are coming from and where these solves and how we work through them are navigating probably closer to hundreds of years ago, for the methodology on how we set them up to solve, it was not easy to write fractions. Okay? Some of you have already tried typing in fractions into the computer. It's 63.6 miles, but I'm going to underline it, and then I'm going to hit return, and then I'm going to space the hell across so that I get 1 hour underneath it. That's why people use the slash, because that's a horrible methodology for trying to write that notation in. Okay? It also removes our understanding of where that content is. So it requires a secondary interpretation. Right? So get that interpretation down on paper right away. Get it into that clear numerator-denominator notation. Right? The next part, it says, how many days does it take? Which means days. I'm being asked to solve for days. That's my goal. That's what I want. Okay? And I'm traveling 574.5 kilometers. And then that's all it gives me. There's a lot of implied content that you have to bring in because theoretically you already know that. Okay? So one of them, this person solving already started to do 1 mile equals 1.61 kilometers. Okay? They noticed that the distance measurement changed, so they're probably going to have to do some kind of distance conversion, so they set that up. Okay? What about the time unit? Did the time unit change? Yeah, we went from hours to days. Okay? And depending on what you see is ultimately where you start this question. Okay? And that becomes some of the problem behind this. If this question is rewritten, where I start with how many days does it take to travel 574.5 kilometers when traveling at a 63.6 miles per hour? Subtle change in the language, the success rate for students completing this question goes through the roof. As written, students are like, I can't solve it, and get stumped and struggle to navigate. But if we swap the order of it, all of a sudden everybody can solve it. Why is that? You've been trained unconsciously, primarily by unconscious instructors, to use a number first in your calculations. And the number you use first is the very first number that appears. And when we swap the order, guess what number you should use first? The 574.5. If you use 63.6 miles per hour first, you get the wrong answer, rather spectacularly. Okay? And that's because you're following a flawed process. The process is exactly what we talked through when we looked at the mole one last week, right? It's the beginning of the week. So we want to follow that same process now. What do I want? Days. That's my focus. That's what I want. So everything I write now on the left has to have that central focus in mind. I need to deal with days. Okay? So I can now go back to my given information and say which of those pieces of given information gives me information about days. And I should come back with the unfortunate answer of none of them. Okay? So now we can ask a different question. What is days a measure of? Days is not a measure of hours. What are hours a measure of? Minutes. It's a measure of time. So when I'm looking for this, I'm trying to find days, my measure of time, to appear in my numerator on top. So now I can go back to my given information. Do I see a measure of time? Is hours a measure of time? Yeah. So what do I want to do? I want that time unit to appear exactly where I want it to appear in the answer. In the answer, where do I want my days to appear? In the numerator, which means on my work side, where does my time unit need to appear? In the numerator. What's my time unit? Hour. Is it just a number of hours, or is this time unit attached to something else? It's attached. It's attached to, okay, I'm going to harp on you a little bit. It's attached to 60, no, it is not attached to a number. What is it attached to? It's attached to the unit of miles. Do I know the number? Do I know the conversion factor that relates hours and miles? Yeah, that's the numbers in my expression. Where does the 63.6 belong? With the miles. Where are miles happen to be written? In the denominator. What needs to go with the hours? 1. Okay? Let's push on this. I'm going to harp on this every time we deal with conversions. What you are likely going to write out is the final answer. You're going to slowly piecemeal everything I put down, and you're not going to write a single note about the words that I'm saying to describe how to solve the question. Which then means when you get home and you try to solve a conversion, you're like, I don't know what to do because all the units are different. Check your notes. Do your notes say how to solve the question, or do your notes show that you solved the question? Okay? The important part here is not the numbers. It's not the units. It's what question did we ask that allowed us to place those things. Okay? So cool. What question should we ask now? Easier. Do I have my answer? No. So what does that mean? I've got to do something. Okay? Well, what do I want to do? So I can look at my left side. It needs to look like my right side. Do they look the same? No. You now have a crossing point. You need to either work on hours or you need to work on miles. What do you want to work on? Hours? Okay. What needs to happen to that hour unit? Does it show up in our answer? No, which means it must cancel. I have to place the hour unit in the denominator so that it can cancel. Do I know a number to attach to my hour unit? Where in the question does it give me a number to attach to my hour unit? I see a 1. I can put a 1 there, but if I put a 1 there, what else am I doing? I'm also attaching the 63.6 miles because that's exactly what that showed. Can I do this? It's a nasty question. Yeah, absolutely, I'm allowed to do this, 100%. It's perfectly legit. Okay, what happens if I do this? I cancel all the work I've started. Do we like that idea? Okay, so let's backtrack. That was a bad idea. Let's try again. Do I see a number in the question that ties me to hours?
24 hours a day.
In the question? No. But I do know I could convert hours into, I'm going to be obnoxious, minutes. 60 minutes is an hour. Perfectly legit. This is why you don't write things down for the record, because that's not useful. Okay? Is that a useful conversion to do? No. So again, instead of jumping on the numbers, focus on the unit. Is it useful for me to convert hours into minutes? No, because what do I want to do? I want hour into days. You mean I need to focus on what I want? Yes. That's the point. That's why we start with what we want. Is that conversion a valid conversion? Do I know numbers that relate hours and days? Gabby did. She said 1 day is 24 hours. Where do I write the 24? On the bottom. No. With hours. Associate it with the unit. What happens? Hours cancel. Did I want to get rid of hours? Yeah. What else happened? I have days. Isn't that what I wanted? Cool. So what do I do now? Do I have what I want? No. I have days per mile. The mile unit is still there. I don't want the mile unit. So now what do I want to do? I need to cancel out miles. Okay. Do I know the number of miles? Nope. Now I'm stuck in a weird gray area. What should I do? I need to convert the miles to something. Should I go miles to feet? Why do I want to go miles to kilometers? Miles is a measure of distance. Kilometers is a measure of distance. If I can get this miles into kilometers, I now have something that I can tie together. So I could try and go miles to kilometers. Does that conversion factor exist? Yeah? Where does it exist? Thankfully, right above us because someone provided it for us. So touche. Thank you. Assuming they did it right. 1 mile was 1.61 kilometers. What happens? Miles cancels out. And we get this long distance cancel. Are we allowed to do that? Yeah. Multiplication and division are communicative. It does not matter the order in which we do it, so we can do a long distance cancel. So now what do? We could go through and multiply everything. Would we get our answer? We want days. I got days, but I also have kilometers. Do I want kilometers? No. So what has to happen? I need to put kilometers in the numerator. Why does it need to go in the numerator? So that it could cancel out. Do I know the kilometers? Does the question tell me a number of kilometers? Yeah, it does. So what do? 574.5 kilometers. What goes in the denominator? 1. The number that does not change the value of our top number, and a unit that does not change the unit of our top unit. Kilometers cancels, miles cancels, hours cancel. What unit would we have? Days. Is that what I wanted? Now what do? Now you move to the calculator, and now you can do all the math. This sets up all of that calculation in one glorious run. Okay? That run now gets us to a final answer. Okay? If we again talk through the approach, remember when we looked at the initial question? The initial question was, as I mentioned, that if I swap the order on those two sentences, everybody gets it right. If you start with the 63.6, you're starting with it in the numerator. Where does it need to show up? That number needs to show up in the denominator. That's why you solved for it wrong. If we swapped the order and we brought the 574.5 in front, the very first number we saw, we would end up reflexively placing it in the numerator, conveniently exactly where it needs to be for our conversion, which is why when we swap the order of those two sentences, everybody gets it right, because you're falling into the patterns that you have learned in every other class, which was ultimately to not think. Yay. The answer, I believe, that comes out is about a quarter. 0.25-ish days. You actually have a number?
Yes, like 0.2.
0, 2, 3.
Something like that. Yeah.
Okay. 2, 3, 4 days. Is that going to be good?
It's specific. No.
Why is it not good? We got to worry about sig figs. How many sig figs should show up in our answer? Ooh, and this is fun. All right, we wrote a bunch of numbers down here so we could go through and look. This 574.5 has how many sig figs? 4. 1.61? But that says 1. How many sig figs? This is a dodgy one. That should actually read 1.00. Okay? As a conversion, if we wanted more than 3 sig figs, we would continue to add significant digits to our conversion factor between kilometers and miles. 1 day, 24 hours. How many sig figs? 2 is wrong. Try again. 3, also wrong. 1, also wrong. 5, no. Infinite, that's a definition. We've defined 24 hours is equal to 1 day. Last one, how many sig figs? 3. How many sig figs do we have? Our answer? 3. So 0.234 is actually correct. Because that has 3 sig figs. 2, 3, and 4. The 0 in front is not significant because it doesn't have a significant digit to the left. And I've done this question a couple times with a couple different locations. I believe this one is Disneyland. Right? It takes about a quarter day to drive Disneyland. Is that right? Yeah. Ta-da. Now you know. Make sense? Someone say no. That's fine. Do we have questions about it? Okay. Slow it down. Follow the process. Okay. The problem that I've got with the stuff up here isn't necessarily that it's wrong. It's that its consistency is below 60%. So if you consistently get 60% on the exams, are you happy? I'm equally unhappy with that result. So I need to get you a process that works more consistently. This process that we just outlined works every time for every conversion. Be it Gen Chem, be it OChem. Well, you don't do conversions in OChem. Be it fundamental, be it nursing. Right? Be it, because you do conversions in nursing, right, with the drugs and dosage and mass people and all that fun stuff. Okay? This process will always work. Track your units and you create a system that works. So the next thing I might ask to this is if this process always works, why do we show other things? It can come back to how you learn. I would argue what mathematics is trying to do is to set up ratios so that you understand ratios. Once you understand ratios, then what should you do? Advance. Stop digging into your ratios. Okay? This is the advancement of dealing with your ratios. Okay? The other approach, here's a formula. You need to multiply, or I don't even know the formulas because I'm not good with them. Okay? You have to memorize this formula and then you get the answer. That works great when it matches that formula. But what if it's not that formula anymore? You've now memorized a useless piece of information. Okay? So be very careful when someone tells you, you should use this formula. That's a problem. Eden, did you have a question?
You're gonna put like not a cheat sheet, but like kind of conversion factors on the quiz.
So, yeah, are we good with everything that's up here? Can I delete it all? Okay. And I don't remember if it's in this one. It should be. Yeah, it is. This will be on the front cover, just like the last one. So the very first page of the exam has all of this stuff on it. The back side, I'm going to try to get a better periodic table. If someone would send me an email, Marcy, I think you complained. Did you complain? Who complained? Someone complained about this periodic table. Whoever complained, send me an email so I can get a better one. What I'll try and do is turn it, make it look nicer. It's still got to be black and white, but you've got to let me know. I would recommend you tear that first page off so it's staring at you the whole time you're taking the exam. Okay? It makes it easier to navigate your flow. And then we'll just staple it back on at the end. Does that make sense, Eden? And if you look at that, hopefully what we see in there is the conversion between kilometers and miles. There it is. Make sense? Other questions? Sure. Where's that density one, Karen? .37 is a density, but it's not a calculation. 35 is that bean one.
Yeah.
The bean one's a good one.
34 is the 10 to the nice nanometers.
Yeah, I don't think I want to walk through that one. Here's another conversion one. This one harps on kind of a different aspect behind it. We'll just kind of, actually, no, we'll leave those. Follow the process. Set it up, navigate the process all the way through. This question, for those people that are like, I don't need to set up this process, is actually written for you. Because I get a lot of people telling me they don't need a special process to do these kind of conversions, and this particular one isn't one you need a process for, but it can come in handy. So again, start putting it together. Okay, let's talk a little bit about it. I want to point out a couple things. First and foremost, in walking around listening to what people were saying, a very common question that comes up frequently with conversions is, dang, should I multiply or divide? No. No, you should not. Okay? What you're focusing on at that point is dealing with the mathematics, not the units. Track your units. The units will tell you what to do. So what ends up happening is you're so hyper-focused on the numbers that you start jumping straight into the mathematics. Slow your roll and focus on the process. Okay? The next thing that I'll point out, okay? Relatively minimal calculations here. But if we go through and take a look at those answer choices, you'll note that those answer choices all have a lot in common, because the only things we're really dealing with are multiplying 2.3 times powers of 10 and 1, which means the number 2.3 is going to stay constant. The only thing that's going to change is the powers of 10. And if we consider our powers of 10, we've got -2 and 3. Okay? If we ignore the negative sign for the moment, we could get 5. If we multiplied, we could get 6. If we added those two with the negative sign back in, we could get 1. We could get -1. We could get -5. Take a look at the powers of 10 for each of those answer choices. And what you should notice is like, well, that looks like all the numbers you're throwing out at me. Yeah, it is. Okay? So you have to understand the process by which you do this, because if you just jam random numbers together, guess what's going to happen? You're going to hit one of those answer choices. You'll be like, hooray, I know what I'm doing. No, you don't. Understand your process. So, reading the question, what do we see? Okay. We see 1 bean is equal to 1.0 centigrams. Cool. What else do we see? I've got 2.3 kilogram packages. If we wanted to get real fancy on it, we could put the package label on that. You'll see very quickly I'm going to drop that off because I don't want to write it. And then what else should we see? What we want. What are you trying to find? Okay? Look for your question word. Who, what, why, when, how. Is that all of them? Look for your question word and then try and track for a unit that comes relatively quickly after it. We're looking for beans. So to the far right, I want to know the number of beans. Cool. Go to my given information. Do I see any information about beans? Yeah, that blue line tells me beans related to centigrams. Where do I want to place my bean unit? I want it in the numerator because in the answer it appears in my numerator. What numbers? 1 and 1, relatively straightforward. We weren't trying to get tricky with that. Do we have our answer? No, so what needs to happen? You need to get rid of the unit of centigrams. This is where things can go a bit wonky. Do we know how many centigrams we have? We look at the question. Does the question tell us how many centigrams? No. It tells us we have 2.3 kilograms. It tells us one bean is 1 centigram. But I don't know the just raw centigrams. So I'm going to have to convert the centigrams into something. What do I want to convert them into? Okay. What would I like to turn them into? Let's go with that one. It would be really cool if I could get into kilograms. Centigram directly into kilogram, and then I got it in one conversion. Can you do that conversion correctly? My observation, no. You can't. Sorry. Okay? It's going to come down to your odds of how you put that together, and again, it comes down to a 50-50. Okay? If we look at our given information, the stuff we're supposed to memorize, okay, 1 C unit equals 10 to the negative 2 units. What's the unit in this case? We're asking about grams. Okay? So I can relate my centigrams to grams. 1 centigram is 10 to the negative 2nd grams. We had a conversation earlier on in Unit 1, I believe. Our power of 10 always goes with the core unit. Grams is the core unit. Centigrams is an advanced unit. I've added a skeleton on top of it with that C. What happens? My centigram unit cancels. Great. But what did I bring in? I brought in a gram unit. Did I want to bring in a gram unit? Nope. So what am I going to have to do? I'm going to have to cancel it. Okay, do I know the grams? Nope. What do I know? I know the kilograms. Do I know that conversion factor? Yeah, back to some either what you've memorized or given information. I don't remember if it's on the front of this exam or not. It shouldn't be. 1 kilogram is 10 to the 3rd grams. Where does the core or power of 10 go? With our core unit, grams, 1 kilogram underneath. What happens? The gram units cancel. I'm not done yet because I need to get rid of the kilograms. So where do the kilograms show up? In the numerator, so it cancels. Do I know the kilograms? 2.3. What goes in the denominator? Stuff that does not change my numerator. What happens? Kilogram units cancel. What would my unit be? Beans. What do I want to solve for? Beans, which means now it's a question of can I answer this into the calculator? Okay. And what frequently happens is that middle part. That's the part that people don't know what to do with. And they either multiply or they divide or they shift the decimal, and they end up shifting the decimal in the wrong direction. Okay? The answer that comes out of this is 2.3 times 10 to the 5th. And we now have our answer. We come in with E. Are you getting it right with a different method? It's multiple choice. Do whatever you got to do. Okay? But if I go back and look at your work and it's not there and you get it wrong, you're just going to get I told you so. Yes?
I switched the centigrams and the grams, and I got 23 beans, which is not correct. But
So is it okay? No, it's not okay. Okay, because you got it wrong. Okay? But what I would bet was happening is, again, the thing that we talked about back in Unit 1 with our initial numbers. 100 centigrams is 1 gram. Okay? You can do that process. It works. You swap that in, your numbers would change, and it fixes everything. The problem is can you do it consistently correct? And my view, no. No, you cannot. Your ability to maintain 100 centigrams equaling 1 grams and simultaneously maintain that 1 kilogram is equal to 1,000 grams, you're not going to do it. You just screw it up.
So, actually, so for the 1 centimeter over 2 to the negative 2 power, or 10 to the negative 2 power, instead I put 0.01 centigrams over 1 gram.
Yeah. So again, you did the exact same thing. You did the calculation in the wrong spot. You're doing the mistake that's happening up top. You've now shuffled 2 different conversion systems. Okay? And therein lies the problem. You need to be consistent in whatever conversion system you go through and use. Okay? For those people that have gone through biology, you're seeing a second conversion system. For those people that haven't, it should just be 1 conversion system. All you're doing is manipulating the powers of 10 as I've told you to go through and do. Because that works. When? Always. When does the other conversion system with the hundreds and all that work? When you've memorized it correctly. You won't. Or you won't consistently. Okay? And so you're potentially stuck in a problem of going back and forth. This is why, guess which class you should have first, chemistry or biology? Chemistry. You know who disagrees? Biologists. Which is probably why most of you have had biology first. Sorry, you were misadvised. And now you have to relearn all the content that the biologists tried to teach you about chemistry, and they suck at it. And if anyone wants to challenge that, you're welcome to. There's a reason I don't teach biology. I suck at it. I'm not paid to teach biology. Biologists are paid to teach chemistry, and it's infuriating. Hooray. Next. Should we do another one? Cool. Another conversion factor, sorry for the scrolling, all the way up at the top. I would argue it's a little bit more straightforward, but it again depends on how you approach the question. You go slowly through it, you should be good. You go fast, you increase the odds of making a simple mistake. An automobile engine displaces a volume of 498 centimeters cubed in each cylinder. What is the displacement of a cylinder in millimeters cubed? Show all unit work. Be specific. Should get rid of that because that gives you some idea of what you're supposed to do. Okay. Set up your unit process. See what you come up with. Do we need to know what millimeter is? Actually, we need to know centimeter and millimeter, don't we? Oh, God. Wait, no, a centimeter and millimeter. That's not that bad. I know that one. Okay, so we could write down that we're being asked to solve for the volume. Okay, the volume in what unit? Millimeters cubed. Okay, now what do we do? Okay, so we could start with a process by placing millimeters in our numerator. Okay, do you know anything about the milliliter? That one, double M. What's that? Okay, and that is an entirely open-ended question. You can say yes, you can say no. If you feel you don't know anything about millimeters, then you say no. If you feel you do know something about millimeters, then you say yes. So we'll call this one the yes group, and we'll call the bottom one the no group. If you don't know anything about millimeters, you're not going to write millimeters there. So what are you going to write instead? What do you know? Do you know anything? Mostly right. For the sake of the recording, I'll get gross and nasty and flamboyant. The statement was 498 centimeters. Okay? No and no for a couple reasons. Number one, where you started. Where did you start? 400. No, I don't want to start with 4 anything because 4 anything is not a unit. Focus on the unit. So what you're telling me is that I have some number of centimeters. And again, no, I don't. And this could just be because it's really, really small. I have centimeters cubed. Okay? I have centimeters cubed, and I do happen to know that number, 498. Okay, what do I place in the denominator? 1, because I want to place something that does not affect the size of that number, nor does it affect the unit. Okay? So for the people that didn't like the millimeter starting place, you've got a starting place. For the people that liked the millimeter starting place, you said you knew something about it. What did you know? Okay? Harped on everybody else, so I'm going to harp on you too. Okay? We know 1, no. Okay? What we know is that millimeters can be converted into meter. Let's just call it a long day. Okay? Based off of those units and my conversion factor, I know 1 millimeter is 10 to the negative 3 meters. Cool. All on the same page. Again, it's a subtle, perhaps whiny thing to complain about, but it's trying to, again, get you to focus on the unit through driving these conversions, not the number. Okay? So we're going to follow the yeses or the nos? Yeses. What did you see next? Okay. So you said you don't like meters, so you want to cancel it, and you want to convert it to centimeters. Okay. Do we know that conversion?
10 to the negative 2 meters is 1 centimeter.
Okay. What happens? The meters units cancel. Cool. Should we continue the no's or the yeses all the way through, or are we going to bounce back and forth? Let's continue the no. Okay. No, what do you guys see? I'm just trying to make this as much brain twisting for me as possible. Lovely. Is centimeters cubed your answer? Okay. So what do you got to do? You would need to get rid of centimeters. Okay? Is that it? What do you want to convert centimeters to? Millimeters. Do you know that conversion? Okay. This comes down to how successfully can you blend two conversions. We have centimeters to meters, we have millimeters to meters. If you can blend those, you're golden. The issue is, consistently wise, I don't think you can. Okay? And because I don't think you can, sorry, I'm going to say no. I'm not going to do that work. What should you do instead? Meters. Okay, do you know that conversion?
Yes.
Yeah, we know 10 to the negative second meters. It's 1 centimeter. Yeah? Anybody notice anything interesting? Oh, it's the same thing. That's cool. Didn't have to be. Okay. And the yeses, we canceled the meters. And the no's, what are we canceling? I'll give you that centimeter. Then what am I canceling? Said another way, what is 2 to the 3? 2 times 2 times 2, which equals 8. Let's drop the 8 part. Let's not worry about that. And I'm going to make that 2 a centimeter. What's canceling? 1 centimeter. And that 3 now becomes 2. Have I gotten rid of centimeters? No. Okay. Where to now? Yeses or no's? No's got to the dilemma first, so I would argue no's, but I'm fine with yeses. No's? Why did we do our conversion? Why was this conversion into existence? 10 to the negative second meters to centimeters. Why did we do that? To cancel centimeters. So what do you think our next step should be? To cancel centimeters. Okay? The whole goal was to get rid of that centimeter, so let's continue that process. Okay? And for those of you watching what I just wrote, you should yell at me, because where did I start? I wrote the number first. Should focus on the unit first.
So how do you know when you cancel centimeters? Because I thought there was 2, like, in your equation, or no?
Let's again look through the process. Okay? Let's do it.
Is it because it's a power of 3 and whatever? So you have to get it down.
So when it said centimeters cubed, it was centimeters times centimeters times centimeters. Our first one got rid of one of them. What's the second one do? Get rid of the second. Our whole goal was to do what to the centimeters? Get rid of it altogether. Which means, man. I get to do it yet again, and my centimeters are now all converted across. Do I have my answer? No. And yeah, there's a lucky sign in this. What do I got to do? I got to get rid of the meters. So what do I got to do?
And if you're getting rid of something, it's going to be in the denominator?
So good question. When I get rid of something, should it be in the denominator? Depends. What does it depend on? What are you getting rid of? Where is it located? If I'm trying to get rid of something that's in the denominator, I want that unit to appear in the numerator so that they cancel. It's in the opposite location of where they're at. So that's why in these systems we've been placing them in the denominator. Cool. We want the meters to be in the denominator, and what do we want to appear in the numerator? Millimeters. Do we know that conversion? Yeah, 1, 10 to the negative 3. And you're already shaking your head because you're like, I could just write all that stupid stuff out again. Yes, but. What is that calculation in orange? It's a repeated calculation, right? Which equals? What does that mean I could potentially do down here? I could do the same thing, and I could cube it. I do have to be a little bit careful on that, though. I have to make sure that I cube those numbers, which means that value inside is 1 over 10 to the negative 9. And if you're like, I can't do that math in my head, that's okay too. Use parentheses on your calculator. Okay? And your calculator can do that calculation for you. But you have to recognize the power of that exponent. And if you don't like exponents, then guess what you like? Writing it all out. Those are your two options. Hooray.
Wouldn't you cube that equation and not the 1 millimeters over centimeters?
What do I want for a final answer? Millimeters cubed. So I still need to cube the millimeters out here. So that cubing distributes to everything within that, including the power of 10 and the meters and the millimeters.
Are you also cubing the equations to the right?
In the orange one, we said that we could have cubed that instead of writing it out. Okay, that comes down to personal choice and what you wanted to do. I wanted to write it out at least once so that you could see it, and then I didn't really want to have to write it out again. Does that make sense? So let's erase some of the pretty colors in between. Whoops, we needed that cube. What happens with the yeses? You're going to encounter the same issue, okay? But I would argue you're not seeing that issue happen right away, right? Your meter's canceled. Great, okay? So what would you bring in next for your yeses? You want to bring in centimeters? Okay, do you know anything about your centimeters? Okay, why are you doing the meter conversion? Yeah, interesting. This yes one hits a weird wall that makes it difficult to navigate through. Okay, we want to get rid of centimeters. That's true. But if I convert to meters, I'm dead in the water. I don't know the millimeter conversion. So what number do I associate with that centimeters? 498, but it's not 498 centimeters, it's centimeters cubed. Okay? That might help me recognize, oh crap, what do I got to do back here? I got a cube. Okay? And theoretically here, I should have seen that I needed to cube because I wanted cubed there. It's going to come down to what you see as you navigate. Simplest approach is that yes line, but again, you must deal with the cubing. And that if you forget the cubing in that, you shaft the whole question. And conveniently, it matches one of your other answer choices. Kind of, sort of? Feeling excited about conversions? Okay. This one becomes extra tricky because it's dealing with the distance measurement of volume. Distance measurements of volume are nasty because they have the cubes. Okay. You could also look at surface area, I think, for squares. If you're looking for surface area, that's just going to introduce squares instead of volumes. Why would we typically not look at squares? Surface area? Chemistry deals with the three-dimensional world. So we're going to look to 3 dimensions when we look at our volumes. Kind of make sense? Questions? Okay, I'm going to delete everything.
Just one more. I'm so sorry.
No, you don't.
I'm just confused about the cubes. Like, again, like how do you know when you're cubing it?
Look at your answer. What do we want? I want millimeters
Oh, so you have to
cubed.
everything in the equation. Okay.
Because what I'm solving for shows a cube unit. That's why I have to deal with all the cubes. Anybody see any potential reasons why scientists might have invented liters? So that we didn't have to deal with cube units. Okay? So if you define a new measurement system that gets rid of the cube unit, you don't have to stress about it. All right, so that would be a good explanation for why we would do that. Other questions? I don't know. I didn't do the math. Did anybody do the math? 498, it was centimeters cubed. Make that a 6.
So 498 times 10 to the
10
second power?
to the negative 9. So it should be 498 times 10 to the negative 6 times 10 to the 9th. 498 times 10 to the 3rd. Did that kind of fast. I'm not great with numbers, but I think I got that. Yeah, it is. Other questions? Everybody's getting excited about leaving. Gee, man, Christmas. Okay. So, where will I end? Oh, when's the exam? Next Thursday. When should the practice exam be done? What is today? Your exam is next Wednesday. Sorry. Next Wednesday. When should the practice exam be completed? This Friday. This Friday.